Okay, next one more important concept is process management. So generally, what is a process first? A process is a program under execution or any running instance of your program. Any running instance of your program is called as a process. So like here, a process is a program under execution or any running program or a command given to Linux system is called as a process. Yes, a process is a simply unit for provisioning system resources. So it is any program, application or command that run on a computer. A process is created in memory in its own address space when a command or program or application is initiated. So this is the what very important interview point. Please understand. So a process is created in memory in its own address space when a command or program or application is initiated. But the operating system tracks processes through a process ID. Each process in the system has a unique PID. The priority index of a processes is called NICE in Linux operating system. But the default NICE value is 0 and it can vary between 20 to minus 19. So overall here is the what 40 NICE values. Please remember the point, the lowest value is the highest priority here. So the lower the niceness index, the higher would be priority given to the task. So a process can be run in two ways. What are those? Foreground process and a background process. Okay, so remember everyone, very simple point, a process is a program under execution. So if you give any input like execute command or running application or it is program or anything, so everything is created a one process with back and one process ID. So every process ID is unique ID in the OS. Then what are the two types of processes? First one is foreground process, second one is background process. So what is the difference between foreground process and background process? Every process when started runs in foreground by default. So means user execute any program, so by default the process is the what? Foreground. So a user can be done only one process at a time. So best example Firefox. So now I will show you here, observe. Okay, for example, if I run the word Firefox, so Firefox is the command to open the Firefox. So now it's running, it's trying to opening the what? Mozilla Firefox browser, right? So now it's successfully opened. So now what happened in the back end, see that, so the cursor is waiting for next job. So Firefox is actually running, the backend Firefox browser is running, but the cursor is waiting for next job. So these kind of jobs are foreground jobs. These kind of jobs are foreground jobs because the user can execute only one job at a time. So while running the job, it is not possible to execute one more job. It is called what? Firefox. It is called what? Foreground jobs. Okay, now you want to interrupt the foreground jobs, then you can use Control C or Control Z is the option. So if I run the word Control C, then the job is what? Successfully interrupted. It means you want to cancel the what? Any foreground jobs, we can use Control C or Control Z is the option. Then what is the next important thing? So the next important thing, background process. What is the background process? A user can be done in parallel with the process running in background, since they do not have to wait for the previous process to be completed. So no need to wait for the what previous process to be completed. So in that case, you want to run background jobs, adding ampersand along with the command starts it as a background process. Okay, after running the job, the user, you can add the what ampersand. Ampersand is nothing but what, when the ampersand is added, then job sits what background. Without ampersand, then it is a foreground. So now see that Firefox space ampersand. So then what happened, the job is running in the back end, but the process id is what successfully created with 6221. So now here is the what the user, the point is the what here, see that. So in the background jobs, so do not have to wait for the previous process to be completed, because the cursor is ready for next job. So the backend Firefox is running now with one process id with the id value 6221. So when you add the what ampersand after the command, then it is a what background. Without ampersand then it is a foreground. So now this is the what important thing. So mostly any waiting jobs, any weighted jobs, then we'll go for the what ampersand option. But initially every job, for example simple execution date is successfully executed, so these kind of jobs are what foreground is the good idea. But you are copying or you opening Firefox, or sometimes the jobs will take long time, so that kind of situation better to use the what ampersand, the jobs running better with what background. So now the user how to find what are the jobs running in the back end. So then you can use jobs is the command. So job is the command to find the what background jobs list. Okay, right now only one job is running, which is Firefox. So this is the what important information. So what process ID, then ps is the command to find the what process IDs. So now Firefox is running 6221. So the backend browser is the what 63, the front end browser running with what 6317. The browser web extensions are running with id value is what 6387. So this is the way to find the what job IDs. So you want to list, like it is called what full description of the jobs, ps space hyphen l. So the same jobs with running the what id values, uid values, parent process id values, nice values, and everything. See that every value starts with what 0 of nice value. I told you just now what is that. So the nice value starts from 0, nice value starts from initially 0. So you want to change the priority of nice values, then you can change it, but priority value should be plus 22 minus 19. So the lowest value is the what highest priority. So now jobs are running here, but here you want to kill that jobs, ps is the command. Sir, I want to kill the what Firefox, then we can use some important kill commands are here. What are that? So process kill is the command. What is the process kill? Here the kill command accepts process id as an in a parameter, that is called what PID in a what parameter. So this is applicable only for the processes owned by the command executor. So what is the syntax to kill the process? Kill space signal space PID. So directly you can apply kill space process ID, but sometimes some processes are not killed without signals. So then what is the signal actually? So signal means it is our what software interrupts sent to a program to indicate that an important event has occurred. The events can vary from user request to illegal memory access errors. So you want to verify the signals, kill space hyphen l is the option, but lot of signals are there. But in Linux the very three important signals are signal quit, the id value 3, signal kill, the id value 9, signal term, the id value is 15. But now once again, signals are software interrupts. It's sent to a program to indicate that an important event has occurred. So you want to kill the process, you want to quit the process, I want to terminate the process, then we can use these signals. But mostly in the environment people are using kill space hyphen 9 is the process id, then it is 9 means signal kill. Okay, in case kill space 15 space, so it is your process id, then it is called what? So to terminate the what? Process. So now how to use these programs, how to kill the process. So first important thing, if you run the what? PS command, okay, I want to kill this process because I don't want to run this Firefox, then kill is the command -9. 9 means what? To kill the process. Which process you want to kill? 6221, that is the what? Process ID 6221. So then enter. So now successfully Firefox is killed. Then check it PS, so no jobs are running, or even PS plus -L, so now there is no Firefox related running here. Okay, so this is the great way to kill the word processes. In case more jobs are here, then people's how to find the word jobs. Then Firefox, one more time I will running the job, Firefox %L. So now job is running in the backend, and check it, your jobs PS command, okay, Firefox is running. But how to find in case more jobs are running, then PS space -L or PS space -EFL, then we can use by using grep-i. I want to find the what? Only Firefox job. So now I told you Firefox grep and piping combination. Okay, maybe number of jobs are running. Okay, number of jobs are running. So that time how to find only Firefox ID value only. So I want to get the what? Only Firefox job ID information. Then if you run that, only it lists Firefox related information. So this is the 6627 is the what? Firefox job ID information. So now what are the jobs running and sleeping and everything? We can use PS space -EFL, or some people are writing only PS space -EF only. Okay, EF also it is fine. So to find the what? Firefox ID values. Then how to kill the process? Kill space -9. I want to kill the what? Firefox 6627. So now 6627, then it kill the what? Process. But is there any running Firefox? So now PS-EF, then RL or anything, no Firefoxes are running here. So please remember, you want to find the process IDs of jobs. So to find the process IDs, then PS is the simple command, or PS-EF is also command, or you can add the what? L option is there. But what is the EFL? Then you can use the what? Man pages, man space PS. Then here some important options. L is the what? List option is there. Yes. So E is the what? Select all processes. E means what? Select all processes. And then F for process and L for list. So like same thing, here is the what? Options. So you can read the what? Manual pages, and different options are there. But here E for what? All, and L for what? List. Enough. Okay, so now here you want to monitoring Linux operating system. The simple command is top command. So what is the top command? So top will monitoring your Linux operating system. So generally in Windows, how to monitoring means task manager is there, but in the Linux, how to monitoring your Linux, top is the command. So if you run the top command, so now here is the word. See, the first line is, so how long server is up and running. The first line is how long server is up and running, and how many users are connected, and what is the load average of the server. This is the first important line. And now what are the tasks in the Linux? So overall 322 processes. So out of 322, here is the what? 3 or 4 or 2 is the what? Running state. So now it will change every 3 seconds. It is updated to what? Yes, the dashboard. So now 2 processes are running, and out of now 5 processes are running. So it will update every 3 seconds. And now 3117 is the sleeping, and 0 is stopped processes, and 0 is the what? Zombie process. But what is the zombie? I will tell you, wait. And now what is my current CPU utilization? Then 2.4 CPU utilization is running. And next, what is the memory usage? So right now my total memory is 2 GB approximately. So 410 is the free space, and using 1068, like approximately more than 1 GB is used state. And now what is the swap memory? I told you. So it is a virtual memory. I specified twice of the RAM size. Actually my RAM size is 2 GB, that's why I specified the what 4 GB. But now the completely swap space is using 377 is the free space, and right now it is using 318 used space. Okay, this is the first top line information. Then what is the PID, process ID of each process, then which user is executing this process. So here is the what priority values, here is the what nice value, and the next one is it is a what each process virtual memory, it is a each process registered memory, and each process saved memory, and each process state like yes for sleeping or for running here. And then the each process CPU utilization. Now genome cell running with what occupied 6.3 CPU utilization, the top command occupied 0.3 CPU utilization, and now the each memory occupation from the RAM. So now this process is occupied 6.1 memory, 6.1 memory, and now it is occupied 2.3 percentage is occupied memory. And now what time to be what command to be executed, that is called what time command to be executed. So then this is the what time, and our last one is what is the command name. So like this is the what monitoring field. You want to verify the what CPU utilization, memory utilization, and how long server is up and running, how many users are connected, what is the load average of the server, and how much memory is using, what is the free space, how much swap space is running, and everything under the what top command. So you want to cancel the top command, then Q is the option. So Q is the option to cancel the what top command. So now everything under the what top command. You want to monitor it, then simply it is called what top command. And next you want to find any particular process, like you want to find any particular process, then we can use the command PID off. PID off is the command. Okay, I want to find my SSHD process ID. So then my SSHD process ID is the what this is. So right now the SSHD process ID running 1058. Okay, I want to find the what cron tabs cron D process ID. So now the cron D process ID is what 1290. So like even one more command is there, pgrep command also is there to find the process IDs. So like pgrep is the command, I want to find the what cron D. So then what is the cron D ID value, then 1290. So actually you have two commands to find the what process ID, simple. So you want to get any process ID, you can use ps-ef also, but simple way only particular process ID, then PID off is the command, or pgrep also is the command. So this is the simple way to find the what process IDs. And next, how to find the nice values, then actually every nice value starts with initially 0 only. I told you what it is. So here nice, enter. So by default every nice value is the 0. And the next important thing, the one more important thing, so how to change the what nice values, how to change the what nice values. For example, I want to get your what PID of like just I will explain, ps hyphen el by using grep, what is that, cron D. So cron D. So right now the priority value of that is called what niceness value is the what 0, but I want to change the what nice value here. So how to change the what nice value? So then we can use nice is the command space -2. Here is the what -2 means that is like a +2, but that is called what lowest priority is the what highest priority, lowest value is the what highest priority, nice space -2 cron D is the option. So now the process ID value, that is called what nice value is the what now +2. Then what is the meaning of cron D? The ID value is the what +2. Okay, I want to setting up the what highest priority. So this is the what lowest priority, plus means what lowest priority, but I want to set up the what highest priority. So how to change the what highest priority of cron D? Then I want to use minus, actually -10. Actually hyphen, first hyphen is the what syntax option. So now I specified the what -10, then it is called what highest priority because lowest value, then enter. Then check it the what cron D, what happened here. the nice value, okay, fine. So crondy cannot lock var lock in PID, otherwise maybe P7145 resource temporarily unavailable. Okay, the backend is the what crondy temporarily unavailable. So right now, so that's why it is not working. But I will change the what ID value of another process. What it is? Okay, I will open the what one more terminal. So the terminal is one more terminal, and this is like here it is running top command. So the top command is running. So I want to change the what nice value of top command. So then actually nice -2, it is a top command. So then the nice value is running top command. Nice value is what now? 2 is the what nice value of my top command. See that? So 2 is the what my nice value of my top command. Right. So now I want to quit. So again I want to change the what nice value of top command. So now I want to specify only minus 10 value. So then the top value, nice value is ID value is what now 10. So it is the what highest priority. Minus 10 means what highest priority, because lowest value is the what highest priority. So then you want to change any nice value. So then we can use the what command is the what nice is the command. But remember everyone, the lowest value is the what highest priority. And the next very important thing, so you want to renice the what ID value, renicing. So now I want to change the what existing ID value. Just now we completed one important thing. So what is that? Here again the crondy option is there. What is the crondy priority value? So ps-l crondy priority value. So now it is running the what 2 value, but I want to renice the value. So renice is the option, -5 is the ID value. Then what is the process ID value? The renice ID value 2060. So then 2060, then enter. So now see that 2060 process ID old priority is 0, then the new priority is the 5. Then check it now, the priority value of crondy, then ID value process ID value is where? Okay, here is running 2 priority values, that's why it is called what new priority. Okay, one more time I will start the what I will troubleshoot that systemctl and stop. Later will tell you these commands in the networking environment. So again we will start the what process. So check it now, ps-el. Okay, the value of this, okay, PID of then crondy, the ID value of crondy is 7301. Okay, I want to kill first 7301. So I want to kill the what process first. Okay, now we will check it the what crondy. Okay, now priority value is 2 is running. So I want to renice the value. So renice like it is a 5. The priority ID value is 7145. So now the old priority is 2, then the new priority is 5. So if you check the what the process ID value, so now the priority value is 225. So this is the way to changing the what niceness values. So you can use nice command to set up the what priority, and even you want to change existing priority values, you can use the what renice command. So these are the what very important commands in the real environment, how to find the what processes and process IDs. So note point is, so you want to get a like any particular user files and particular group files, so also it is possible. So best example, ps -u, I want to find the process IDs of root user. So right, so now this is also one more important option. What it is? So ps is the command, sir I want to find only root user running processes. So what processes are by maintain, what processes maintained by root user, that is called what, hyphen u is the option. PS space hyphen capital U, I want to find root user processes, then these are the processes managed by root user. Okay, I want to find processes managed by Raju user, then these processes managed by Raju user. Actually no processes managed by Raju user here. Okay, for example, if I log in with another prompt in the Raju user, like su space hyphen Raju, then enter. So now successfully logged in. So previously no processes, now only one process is there, that is called 7402, that is called what, login shell, because just now you logged in the what, Raju user. So that's why one process is backend managed by Raju. If I log out the Raju user, now again no processes managed by user Raju here. So you want to find individual processes, then capital U is the option, space username. Okay, when will you specify capital G, then I want to find the what, here it is called what, cloud team process IDs, what processes managed by this cloud team, what processes running by this cloud team. So now right now they no processes. Okay, what processes managed by the group root, so then oh, these are the processes managed by group root. Okay, so like that you will manage the what, multiple processes in the environment. And the next very important thing, so what types of processes in the Linux, so states of processes, so generally foreground process, background process, but if you execute any process, what is exactly a life cycle of the process, right? So if you create any new process, so initially the process state is ready state, the process state is ready state, from the ready state to maybe the process will go to what, running state. So once process is running, maybe from the running state to waiting state, or maybe from the running state to again in any interruption, then it will go again ready state, or maybe you will go for the what, terminated state, that is called what, exit state. So this is the life cycle. So actually if you create any new process, initially the process state is what, ready, so ready to running, but any running process if you interrupt, again back to ready state, so and then maybe waiting state, or it is called what, terminated state. But what are the states of processes, maybe any process is running state, or any process is waiting state, or any process is stopped state, and finally the very important question, any process with a zombie state. So what is a zombie process? The process is dead but have not been removed from the process table, it is nothing but zombie. See that sometimes the process is dead, but have not been removed from the process table. But how do you know that how many zombie processes are running? Even the processes are dead but it's not removed from the process table, then it is called what, zombie process. So how to find the zombie process? If you run the top command, then here is the what, any zombie process are running, here it is highlighted. Okay, 2 or 3 zombie processes are running. How can you find it? In the top command, here in the right side zombie processes are listed. And then the one more important thing, what is a daemon? So daemon names are background service names. Daemon names are what? Daemons means background service name, so these are special types of background processes that start at system startup and keep running forever as a service, they don't die. So means when will you start up the system, or when will you running on the system, so these daemons are obviously activate your services while booting or after booting service, after booting machine, but these daemons are don't die. But so best example, everyone knows the service name. Okay, everyone install the what, Apache web server. For example, people know that Apache web server, okay, so this is the what, one thing, but actually the system knows only that daemon name is what, httpd. So like Apache web server is the what, front end application name only, but the backend service name is HTTPD, hypertext transfer protocol daemon. So you want to manage web server, Apache web server, you must handle the what? HTTPD only. So start the service HTTPD and enable the service HTTPD and open the configuration file related to HTTPD and everything. So same thing, you want to manage SSH, then what is the daemon name? SSHD. So that is, daemon is nothing but background service name. Daemon is nothing but what? Background service name. So they are started as system task spontaneously. However, they can be controlled by a user via the init or systemd process. Via the init or systemd process. So very important point. So now I will explain what is init or systemd. So init is the first program in the Linux that is executed when the Linux boots up. Remember, so I told you one important thing. See that. So if you find the word processes in the Linux operating system, but every process occupied different process ID values. 2153 genome cell and 2612, like maybe it is called what? VM2LSD, and 5771, like it is called what? Every process occupied one process ID, but one process forever occupied every time only one is the what? ID value of the command, that is called what? Systemd. So here the one ID value is systemd. See that systemd is the service in the backend. It occupied process ID value is one only. What is the meaning? So now observe. So init or systemd, actually in early days Linux operating system up to Red Hat 7, so up to kernel version 3, init is the first program in the Linux operating system that is executed when the Linux boots up. So once your Linux operating system is started, the init occupied, the process ID value is 1 only, because it is a mother of all processes. Init is the what? Mother of all processes in the system. That's why the init program occupied ID value is 1. But after Red Hat 7, the init is completely replaced with systemd. The init is replaced with what? Systemd. So the old versions of Linux operating systems, init is the what? System process. Init is the what? Process. But in the Linux operating system after Red Hat 7, init replaced with systemd. So now the init process ID value or systemd ID value is 1 only. So please understand this point. The repeated interview question is, so what is the first program in the Linux? So even you don't know that time systemd, at least you have to say init is the first program. It is a mother of all processes. It occupied ID value is 1. See, init is the first program in the Linux that is executed when the Linux boots up. So simply it is a mother of all processes on the system. But it is started by the kernel itself. So who is executed this program? Kernel itself. So it is started by the kernel itself. So in principle it does not have a parent process. There is no parent process of init or systemd, because the mother of processes are what? The mother of processes means init or systemd only, but that's why it is a first process. So these processes are started to what? Remaining processes. So that's why the init process always has process ID of 1. So you want to find the what? Process ID, then it is a PID of. In early operating system means init is the what? ID, but now in the latest sense systemd, then systemd ID value is the what? 1. So this is the what? Parent process, and remaining all processes are what? Child processes. So remember, one more time I will tell you the very repeated interview question: what is the first process in the Linux? What is the first program in the Linux? So do you know what is the process always has process ID of 1? Yes, that is systemd or init. Okay, so this is overall process management concept.